Nothing really new here. We're going to take our knowledge of transformations and we're going to apply it to how to transform the graphs of logarithmic functions, which we learned how to graph yesterday. Remember when I talked about how to graph logarithmic functions? Graph the exponential function first, the corresponding exponential function, then switch the table of values, okay, to get the logarithmic one. But just to start, just to sort of warm up, and here's the transformation equation for a logarithmic function. You should know what the letters A, B, H, and K represent. Okay, we have to describe the transformations for this. Tell me a transformation, please.
Vertical stretch.
Yeah. Yes. Vertical stretch. Factor of 1/4. Remember, when you talk about stretches, you must include the word factor. Horizontal stretch by a factor of? Yes. Horizontal stretch by a factor of 1/3. It's always the reciprocal. Takes care of that. Yep.
Horizontal shift by left. Horizontal shift left by 2.
Yep. Horizontal shift left 2. We don't use the word factor when we talk about shifts or reflections. And finally, shift balance. Okay. Okay. So now we're just going to look at a couple of examples where we're going to graph a transformed log function and state some of its properties. Okay. So log base 3 of x minus 1. That means I'm going to take the log base 3 function and do what to it? I'm going to take the graph of that and do what to it? Flip x and what? No.
Shift
Like I'm going to take the log base 3 function, the graph, and do what to it? Move it one to the right. Right? But to get the log base 3 function, do this first. So negative 1, 1/3. 0, 1, 1, 3, and then reverse. So it becomes 1, 3, negative 1, 1, 0, and 3, 1. With an asymptote, remember it's not a vertical asymptote at x equals 0. What's the mapping notation if we take this and move it one to the right? X plus 1 and y. So 1/3 plus 1, well, it's 1 1/3. Y stays negative 1. Next point becomes 2, 0. And then 4, 1. And what happened to the vertical asymptote? It moved to the one right as well. So it's now x equals 1. So we got to remember to draw that in too. So, looks like we only have to put some notches on these axes, and that should be sufficient. So 1 1/3 is about there, -1, somewhere around there. 2, 0, 4, 1. The asymptote moved from the y-axis 1 to the right. And you should be able to draw the curve now. As we go to the left, we're going down along the asymptote, and then this just continues off to the right. Okay. Domain.
Not including negative or not including the one.
Yep. 1 to infinity, but not including 1, yes. H. Negative infinity to positive infinity. X-intercept. Just 2. Y-intercept. None. Okay. This one, I think we're definitely going to want to use mapping notation because there's 3 things to need, right? But remember, first thing, do y equals 2, do a table for y equals 2 to the x because the log is base 2. Get those 3 points and then reverse them, right? So -1/2, 0, 1, 1, 2, and then reverse. Half -1, 1, 0, 2, 1, and remember the asymptote. It goes, remember for exponential functions, it's horizontal, but for log, because it's inverse, it's vertical. The formula for the transformation of the points. X minus 1, because the only thing happening to the x's is they're moving 1 to the left. And I can't hear you. We skip 1. Oh, well then I guess we're doing C. Sorry, I keep forgetting that when I turn the page, it doesn't go to the top of the page. So we'll do this one, then move on. Sorry, this -3y. So what's 1/2 minus 1? -1/2. And then -1 times -3y gives me 3. What's the new coordinate for 1, 0? 0, 0. What's the new coordinate for 2, 1? 1, -3. Where does the asymptote go, if anywhere? Goes to -1. Because it moves 1 to the left. So instead of at 0, it moves 1 unit to the left. Okay, so I need some points there. So we've got -1/2, 3 up here. We've got 0, 0. And we've got 1, -3. And we've also got our vertical asymptote here. So notice it's going to go like this. Because remember, the original log goes like this, but we're flipping it upside down and stretching it. Right? Domain? Right. To, yeah. Range? X-intercept? Y-intercept? Both 0. Okay. Okay, now we'll move up and finish the last one. I don't see a base. 10. So therefore, y equals 10 to the x. The table would be -1, 110, 0, 1, 110, and then reverse to get the log. Well, this is pretty straightforward. Just the y's are moving up 2. The x's aren't moving at all. Okay, which means that the asymptote's not moving at all. Remember, in exponential functions, the asymptote only moves if there's a vertical shift. In logarithmic functions, the asymptote only moves if there's a horizontal shift. So the new coordinate of the first one would be 1/10, 1. Then 1, 2. Then 10, 3. So the vertical asymptote stays here. I got to put a fair number: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's like I only have to go up here. So 1/10, 1, really close to the asymptote. 1, 2. And 10, 3. So it takes a really sharp turn. And I think we've got the domain and the range established. Domain would be 0 to infinity, not including 0. The range would be everything, negative infinity to positive infinity. The x-intercept would be very hard to find from the graph, because you see it's some fraction between 0 and 1, close to 0. So don't worry about this one. The y-intercept? None. Doesn't cross the y-axis. You could figure out the x-intercept algebraically, but I don't see that question being asked. Okay. Okay.